Welcome to another episode of Kovach Chemistry. Today's joke: lost your electron? Gotta keep an eye on them. In today's episode, we're going to talk about moles of compounds and the basis for calculations involving moles of compounds. So let's take a look at some introductory information here. Subscripts in a chemical formula indicate how many moles of each element are in 1 mole of the compound. The molar mass of a compound is the sum of the masses of all the moles of elements present in the compound. So those are a couple important definitions. Next we have the mole map, which is a simplified version of the more complicated one we looked at in section 10.2. And so here you have mass in grams, and then that's going to be converted using molar mass into moles. And moles can be converted back and forth to particles using Avogadro's number. All right, so let's take a look at these questions. Number 1, what are the different types of representative particles that can be used? Remember, your representative particles are over here, and so I'm asking what are the subcategories of these that you could have. So everybody think about it for a minute. Can you name any? Let's see. I've got them under these boxes. Ready? Oops. Atoms, molecules, formula units, our favorite, and ions. Very good. So those are the different types of representative particles that could be used. Okay, so question 2. To convert from moles to particles, that'd be going this direction, we would need to do what with Avogadro's number? Well, we would need to multiply. And number 3, to convert from particles back to moles, so particles back to moles, we're going to need to do the opposite, which would mean we would divide. Okay, question 4. What information should be obtained to determine the molar mass of a compound? Well, you're going to need the atomic mass of each element present. And where would you get the atomic mass, class? Well, that would come from the periodic table. So the atomic mass of each element from the periodic table. To convert from moles to mass, what should we do in this case? Well, we want to multiply by the molar mass. And in step 6, to convert from mass to moles, we would do the opposite and we would divide. All right, a couple more things about the mole map that you want to be aware of. This is our simplified version again. And so one thing that you might want to remember is a little mnemonic device that says multiply out, divide in. Multiply out, divide in. Now this is always going to be with respect to the mole, because that's of course in the center. So when we multiply out, that means we go from the mole out, we're going to multiply. And so on this side, when we go from the mole out to particles, we multiply. So over the arrows that are going out from the mole, we're going to put multiply signs. And over the arrows that are going into the mole, we're going to put divide signs. So you may want to add this to your notes. So remember when you're doing these problems that you're multiplying out and dividing in. All right, now it's time for some practice problems. I'm just going to do some assorted problems from your textbook starting on page 335. Problem 30 says, calculate the number of moles of each element in 1.25 moles of C6H12O6. I still haven't figured out how to do subscripts using explain everything, so bear with me. Hopefully you can figure out what the formulas are that we're working with. So let me move these down a little bit. All right, so we have 1.25 moles of C6H12O6. And we are going to convert that into the number of moles of each element. So we're just going to do a little picket fence, factor label, dimensional analysis, or whatever you want to call it. That means that in the denominator of the next box, we want 1 mole of C6H12O6 because, class, I'm sure someone can tell me, yes, we want the moles to cancel. In the top, we want to know how many moles of each element. So let's start with the carbon, and we would say there are 6 moles of carbon here. And so if we do our math, we will end up with 7.5 moles of carbon. Now, since there are the same number of, the subscript for the oxygen is the same as the subscript for the carbon, you would also have 7.5 moles of oxygen. Now, what is the relationship between the hydrogen and the carbon? That's right, there's twice as many hydrogens as carbons. So let's see, 7.5 times 2 would be 15 moles of hydrogen. So that's all there is to it. You're just really multiplying by the ratio of the atoms in the formula. All right, moving right along, we have problem 31. I'm going to move that, make that a little smaller. Here we go. Determine the number of moles of sulfate ions present in 3 moles of Fe2SO4 which, for those of you that don't remember, that's iron 3 sulfate. And we want to know how many moles of sulfate ions there are. So again, we just break down that formula. 1 mole of the Fe2SO4 is going to have how many sulfate ions? Well, you have to look at the formula. So this is the sulfate. How many of those are there? Yep, there's 3. So you're going to do 3 moles of sulfate ion. What's the charge on sulfate ion? Yep, -2. And so if we do our math here, the answer here would be 9 moles of sulfate ion. Good job. All right, problem 33. Calculate the number of moles of hydrogen atoms in 1.15 times 10 to the first moles of water. Again, I'm having a little trouble using explain everything for scientific notation too, but you can figure it out. So we have 1.15 times 10 to the first moles of water, or you could make that 11.5 moles of water, whichever you prefer. Next, we're going to convert moles of water. And so in 1 mole of water, there are how many atoms of hydrogen? Yep, that's right, 2 hydrogen atoms because of that subscript of 2. So 11.5 times 2, and if we do the math there, we should get 23 moles of hydrogen atoms. Now remember, the rule we learned in the last video is that you do want to include a number, a unit, and a substance. It's a good habit to get into. All right, continuing on, page 335, problem 36A. First we want to identify as molecular or ionic, and then we're going to calculate the molar mass. Remember that we calculate molar mass by adding up the atomic masses of all of the elements. So in strontium nitrate, we see that we have a metal. Strontium is a metal. And then we have NO3, which is a polyatomic ion. So I know that I probably gave it away, but this is an ionic compound. Very good. All right, and let's do the next one then. We have NH4 3PO4. And what is this NH4? And what is that PO4? Yep, you're right. They're polyatomic ions. So that means that this is also an ionic compound. And finally, the C12H22O11. Well, those are all nonmetals. So that makes this, yep, a molecular compound. Okay, now let's go back and calculate those molar masses. Well, how many strontium atoms are present in this formula? That's right, there's one strontium atom. Okay, so anybody who has their periodic table handy, that's going to be very helpful. And so you're going to look up the molar mass of strontium, and then you're going to look up nitrogen, and then you're going to look up oxygen. So pause the video while you look those up, and then tune back in to see if you've got them right. Okay, so you're back, and the molar mass of strontium is 87.62, and we have how many nitrogens now? Well, remember to watch that formula. You've got this 2 right here is multiplied by everything inside of the parentheses, so that means we have 2 N's and 6 O's. So when we go back to our calculating of the atomic mass, we're going to do 2 times the molar mass of nitrogen, which is 14.01, and then we're going to add to that 6 oxygens, which are all 16.0. All right, and if we multiply and add, we should get 211.64 grams per mole. Now let me just say a word about atomic masses and molar masses. You should use the 2 decimal places that are given for most of your atomic masses on your periodic table. So when you have 2 decimal places, your answers should have 2 decimal places as well, in terms of calculation of molar masses. So stick to 2 decimal places. All right, so then we have NH43PO4. So tell me how many nitrogens that is. Yep, that's right. 3 times 14.01 is the mass of nitrogen. Plus, how many hydrogens is that? Yep, very good. 12 hydrogens times the mass of hydrogen, which is 1.01. Some of you are going to start to remember some of these masses, especially hydrogen, because we use it all the time. Phosphorus, we'd probably need to look that one up, and that happens to be 30.97 plus 4 times 16 for the oxygen, and that total will be 149.12 grams per mole. All right, and finally we have C12H22O11. That is the formula for table sugar, sucrose. And so we're still going to calculate this in the very same way. We figure out the number of each type of atom and the mass for each. So carbon is 12 times 12.01 plus 22 hydrogens times 1.01 plus 11 oxygens times 16. And we multiply and add, and we should get 342.34 grams per mole. Ta-da! Okay, last 2 problems. Number 38, what is the mass of 4.35 times 10 to the negative 2 moles of zinc chloride? All right, so you would write down what you're starting with, which happens to be, in this case, 0.0435 moles of zinc, and we want to get to the mass. And so remember, if you're stuck here, look at your map. If you're at moles and you want to get to mass, then you're going to pass over the arrow that's labeled molar mass. And if we're going from moles out to mass, that means we're multiplying out. So we're going to multiply by the molar mass of zinc chloride. So now all we have to do is figure out what that is. So you do the same thing we just did. You're going to add up 1 zinc plus 2 chlorines. And when you do that, remember to keep your 2 decimal places. And so you're going to end up with a total of 136.28 grams. And when we multiply these 2 numbers together, we get 5.93 grams of zinc chloride. All right, and finally problem 40. Determine the number of moles present in 22.6 grams of silver nitrate. All right, so now look at your map again. Now you have mass, and you're going to moles. So if we go from mass to moles, then we're going into the mole, and we're going to divide. So now we're going to divide by the molar mass, and we calculate the molar mass of silver nitrate is by adding 1 silver, 1 nitrogen, and 3 oxygens. And when you do that, you should end up with 169.88 grams. Notice that my grams will cancel if I line it up so that grams are on the top here and grams are on the bottom here. Now what goes up here? Yep, that's right, 1 mole. Are you noticing a pattern where we just have 1 mole all the time? Yes, you should be. 1 mole is either associated with grams or it's associated with particles and good old Avogadro. All right, so if we divide these two numbers here, we will get 0.133 moles of silver nitrate. So it says at the bottom here, we will work on problems 42 to 46 in class. These are fairly challenging problems. If you are capable of solving those problems without too much difficulty, you're good to go. As always, you can review these videos for their stellar quality. Thank you for paying attention and listening to this episode.